Hello guys, welcome back. Now in this session, let us see how exec works. Let me log in. Now ls cd c programs nano exec example.c. Now let's just a basic command that gives that executes exec. Just some basic command. Let us first look into man page of exev. man3 exev. Sorry, man2 exev. No, man3 exec. Here it is. execv takes two arguments, that is a path and other one the argument. Like we can give which two commands should be executed, and then exev is a part of exec family. Now let's try to execute exev. Quit. Let me just write nano exev.c. Now hash include stdio.h. okay, and then uni.std.h. in the uni.std.h we will get the exec file. uni.std.h. now int main printf file is exev.c. next line now printf process id of exec.v is %d by n. Get PID of and now I am defining a character that is pointer args function hello, and I am giving the second argument as null. We have seen in the man page that execv take two arguments. I am giving a first argument as hello. I will later create this hello file, and then I am giving the second argument as null. execv args of 0 and then args. It's like taking address. printf coming back to exev. This printf is for when exev goes to the hello file and then it executes, it come back here. We will know that it came back here when this printed. return 0 and control X, Y, enter. Let me just clear this and close the other tabs. Yeah, now let me create a hello file, nano hello.c, hash include stdio.h int main of. Let me just write printf I am hello.c. and just let us print the process ID of hello.c. process ID of hello.c is %t comma get PID of. Return 0. Let me just compile it. gcc hello.c /o hello. Now let us compile gcc exev.c /o exev. Oh sorry, args is undeclared in. I will just correct it. Yeah, I have given args. It should be args. Okay, control X, Y, enter. I will re-execute. Yeah, it is executed. Now let me compile. Sorry, I just compiled. Let me execute. Let us look what do we get. Yeah, file is exev.c and then it went to it printed exev.c process ID, and then it goes to hello.c. It prints process ID of hello.c, which is same as exec because it's all considered as one process in the operating system. And then it come back. Actually it didn't came back. That's another case. Okay, let's just clear it. We have just returned a 0 value in the hello.c itself. Let's re-edit hello.c. Return 0 here. Let's take it. And then here void main. Control X. I better give spaces. I mean printing next line also. By n. Recompile it. Now execute exev. Yeah, it's the same. It's okay. Let's move on to exev. Let's like combining fork and exev. Here we just saw it didn't came back, right? It just printed like let me execute and show. It just printed the hello and then it didn't came back to exev. That's a problem, and now to reduce that problem we will use fork so that it will come back to exev and then prints I am exev again. Let's try it. type nano exec fork.c. hash include stdio.h. I am including wait.h this time for the parent process to wait. .h int main of int argc char *rgv int return value. Now switch case, I am going to use switch case this time. Before I used a if else block. It's the same and it doesn't matter it is if else or switch. Case 0. If fork is 0, it means the child process have been created. So we will execute the other command in a child process and then come back to the parent process. Let's try. execv argv of 1 address gv of 2 less than 0 and I am ending this. Let me use printf so that I can print this in a stderr file. Printf, if error comes it will print in stderr file, right? I don't have to mess the command line argument. I mean I don't have to mess this terminal. Sorry, execl error. Exit of 200. Now default. Sorry, I forgot to end this if. Let me write default case. Default case just waits. Return value until return value time. printf stderr comma exit status %t by an comma wext status of return value exit of 0. I am ending this program. Let me just compile it. gcc fork.c show exec fork. Yeah, it just compiled with some warnings. It is normal for exit. Let me just now try executing it. Executing ./exec fork. It takes 2 arguments, right? Let us give the path first. ls. Now let us give command. What command it should execute? Let's see the output. Yeah, it work. See, I have got in this path. I have executed ls and then I have shown this. Okay, yeah. Let me just clear the screen. Sorry. Yeah, we have seen how fork and exev works combinedly. Now let's implement that in our own code. Let's try to compile, execute it first. Let's analyze the output. So we have output like this, but we have to get I am coming back to exev like that. Let me just show you. See, until it was executed, but it didn't execute the printf function. Like coming back to exev.c, it didn't exit. It didn't do. Now let's try to use a fork command. Int pid is equal to fork of. Now if pid greater than 0, it will execute the child. Here what are we going to give? We are going to give the this execute command as our child now. Let me just paste it here. Else we are going to give the parent. Now fork executes the both command. Both if and else blocks. Like it executes the child block and then it executes the parent block. Let's just execute it now. gcc exev.c /show exev. Another error. Sorry. Here I have to give what? Forward bracket. I forgot to give that. Let's recompile it. It compiled successfully. Now I am going to execute it. See here, now I am getting coming back to exev. Here what did I get? I didn't got coming back to exev. So fork work. Now let's just modify the fork. Like I am giving to this to parent process. Copy and this to child process. Let's see what happens. Just we are experimenting this. Delete this and then delete this here. Let's see what happened. Let me just compile it. It compiled successfully. Now just execute it. Now see that what happened. It just executed the same file, but now it give im hello.c in another command. And let me just show you by code what happens. It first execute this parent, and then now it executes the child. Sorry, this is the child, this is the parent. Now it just execute the child first, and then it goes to parent, right? Here after it get to parent, it didn't exit, because now the parent has the hello.c, which doesn't return a value. It means which doesn't end until we press some keys. So let me show you. It goes to hello.c, right? After getting hello.c, it just executes it and stops. It doesn't go to exec again, because it is a parent process now. This hello.c is the parent process now. That's why it just stops there, and we will get a blinking button. See, we have until we I pressed this space, and next I have got the username back, but before I didn't get like that. Let me re-execute it. I am going to give this to parent, back to the parent, and I am giving this to child. Yeah, let me give some sleep command, so that it will get time to execute. Okay, let's compile it, see what happens. /exev. Yeah, after 2 seconds, see this. Now after 2 seconds it executed the parent. That's it. Nano exec dot exev.c. What I did is I have kept this parent process to sleep, so that child process gets time to get executed. Let me just give that exit command here, so that we don't get any keys to press. Exit of 0, some 0 or something. Compile, execute. Yeah, it just executed again. That's it. Thank you guys. This is how we use fork and exev combinedly. Hope you understood. Thank you.